Hello.
Hi there. How are you?
Good, and you?
Thank you. Thanks for dropping in.
Mm. So these are the questions that I'm having a little bit. Well, I understand it. I just want to review my answers. Is that okay?
Sure, of course.
Okay. So first of all, I do it in a box first. So I kind of do it like this. And I know this is A, and I know the lengths for A, and I know the lengths for B, but I don't know the lengths for C. So I apply the Pythagorean theorem to solve this
Okay.
equation. Yeah.
Okay, this just hang on a second.
Yeah.
What is the question? What are you trying to find?
Oh, sorry. I'm trying
It's
to.
okay.
I'm
I
trying
just
to.
want to clarify.
Yeah. I just want. We're trying to find the area for this square.
Okay.
hmm So should I keep on going?
Yes, go ahead.
Okay. So I know what A is and I know what B is, but I don't know what C is. So I have to use the Pythagorean theorem. And if I find C, all I could do is multiply that by itself to find the area for the square.
Okay, just give me a second to think about this, okay?
Okay, sure.
Okay,
Sorry.
hang on a second.
Mm-hmm.
So it's just the area of the square, right?
Yes.
Okay, hang on a second.
Mm-hmm.
Yeah, okay. So that's correct. Now, do you have any units of measure, or are they just calling these units?
Units.
Okay. So your first idea was, do you see the purple line that I just put?
Yeah.
Is your first idea to go find that length?
Mm-hmm.
Okay, perfect, using the Pythagorean theorem. And then what would you do after that?
So if I find the length of C, I'll just multiply that by itself to find the area.
That's right, because it's a square. Now, does your question say that this is a square?
Yes.
Okay, because it may look like a square, but you can't be 100% sure. But if it does state that it's a square, then you wouldn't need. Do you see the red that I just put on the board?
Yeah.
Then you wouldn't need to go calculate that if it already says that it's a square. Okay, so that's good. So yeah, absolutely. So your method is fine. So you would call this purple line C, and then you would use the Pythagorean theorem. So do you want to go ahead and demonstrate that on the board,
Yeah.
or is that all you needed?
No, I still need help with
Okay.
this. Okay. I'll tell you when I what I don't understand.
Okay.
Okay, so A square plus B square equals C square, right?
hmm
So I know that A is 1, 2, 3, 4. 4 plus 1, 2, 3, 3. So that 4 times 4 is 16 and plus 9. I think that's 25.
hmm Yep.
Okay. Oh, it's for B. It's not for this one. My bad. This is what I okay. So 25 is the area. Wait, no. Sorry. Okay. So I square that to find the length for
You square root it,
yeah,
yes.
to find the length
hmm
for C. So
Yep.
I know that this is 5, right? So I
Yep.
know that one length is 5, and to find the area, I could just multiply that by 5 too. So 5 times 5 is 25. So the area for this would be 25.
25 units squared. Yes,
Yes.
exactly. Good work.
Okay. It's for this question that I'm having a lot of trouble with. Just the question that I don't understand for this. So I'm just going to do the same thing here and yeah.
Okay, so you're saying you're having trouble with the diagram on the right side?
Yeah.
Okay. So why don't you show me what you think should be done?
Okay, it's just basically the same thing, but the numbers is what I don't really understand because
Mhm.
I don't know how to round it.
Okay, well, now, what is the instruction that goes with this? Could you read me the instruction of this question?
Yeah, sure. So it just says copy each square on grid paper, find its area, then write the side length of the square. It doesn't say where to round it to. So
Okay, well, the thing is that if it doesn't tell you what to round it to, you just usually can maybe keep one or two decimals, and they would be okay. Now, in your book, do you have the answers in the back?
no.
Okay, so usually a couple of decimals is fine. So why don't you work through this problem here and show me what you think the answer is, and then I can guide you along with the decimal answer.
Okay, sure. So just okay. So 1, 2, 3, 4, 5, 6. So A would be 6, and then
Mhm.
B would be 2. I'm just gonna count if these are all the same 2 because it could be different, right?
What do you mean? Where?
For this,
Like, what
can
do you
they
mean? It
all
could,
be different
no,
sometimes?
no, no. If you count the side lengths, like if I'll watch over here, do you see this length here in purple?
Yeah,
What is that length?
6.
Okay. Now, if I do this purple length, do you see the second one that I've just added?
Yeah,
What's that length?
6.
How about this one here?
6, 2. Okay, so all of them are the same.
Yeah. And how about
Okay,
here?
6.
Right. And then you'll notice that you see this over here. That's how much is the red?
Mm-hmm. 2.
What's exactly? So do you
Yeah.
see all the red that I'm adding?
Mm-hmm.
They're all twos. So it doesn't matter which one. It kind of makes sense because if they're calling, you're telling me that your question says that these are squares, correct?
Yeah.
Okay, which means this is congruent to that, which is congruent to that, which is
Mm-hmm.
congruent to that in orange, right? So
Yeah.
it doesn't matter which one you calculate because you'll end up getting that side length, which forcibly, if you calculate one, it's got to be the same in all of them.
Okay.
Okay, so just use the 6 and the 2 for your A and B values and go get your C value. Do you want to go ahead and do that?
Yeah, sure.
Okay, I'll watch.
Okay. Yeah, I also have a question for this. So, if I show this amount of work, will you get it? Will you make it full points or like?
Well, it depends the expectation of your teachers. I know that if you were in my class, I would expect to see the proper form. And I know in my class, the presentation of the work does count for communication. So I guess you'd have to ask your teacher that because every individual teacher will, the expectations are usually correct. You shouldn't just be spitting out the answer with no
Yeah.
proof. There should be a logical process. So I like what you're doing so far. I mean,
Mm-hmm.
you state the formula there. That's great. Now, what value are you using for A?
6.
Okay, so sometimes what I ask my students to do is I do this. Watch carefully. I will go back into the diagram, and you
Mm-hmm.
see where I put the A equals?
Yeah.
So I identify it in the diagram, and then I would go B equals. So then you're
Um,
labeling what you're using where. And now go ahead and substitute. So I see you put the 6 squared. That's good. Now you're substituting your values in. Go ahead. Perfect.
it looks like a 22. Sorry.
It does look like a 22. What is that?
That's the squared. 2 squared.
Oh, 2 squared. Got it. Okay,
Yeah.
of course.
Should I remove it?
No, 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 that's fine. I understand. Keep going.
Okay.
Now, next line underneath that, I should see the 36 plus
4.
the 4 equals C squared. Very good. Now combine your 36 and your 4 on your left side.
37, 38, 39, 40, 40.
Right? So 40 equals C squared.
Okay, see now we're getting to the point that I'm not
Exactly.
understanding.
And this is the part here, and then I'm going to put an arrow, and this is where it gets kind of funny. Now,
Yeah.
you said you're in grade 8, right?
Yeah.
Have you done the algebra unit yet?
Yeah.
Okay, so basically, the principle of balancing is what you do to the left, you have to do to the right.
Mm-hmm.
And over here, you want to isolate your C or get the answer of C by itself.
Mm-hmm.
So you have to find the opposite operation of a square. Now, if you square something, how you get rid of that is you square root it because every math operation has an opposite to undo what you did.
Mm-hmm.
So here you want to have the final answer of what is C, but C is squared. So to get rid of that square, you square root it.
Mm-hmm.
And because I need to square root the right, then I have to square root the left. Right. And then I'm going to scratch this off because I'm scratching off the square root and the square because they cancel each other out. So what happens that you end up isolating your C on the right and then you grab your calculator and then you find the square root of 40. So do you
Yeah,
have your
this is where I'm having a lot of trouble with. So,
okay.
it's 40. The square root of 40 is an irrational number, which means it goes on and on and on. So,
Yep.
hold on. Let me just find the square root of 40. Root of 40. Yeah, so the square root of 40 is 6.32455. It goes on and on and on. So how would I do that? Should I round it to the set on the 10th place or the 100th place?
So what did you get? 6.3245?
Yeah.
Right? 6.2, hang on here. 6 point